Next, let's look at some of the basic mathematical capabilities of Java. Java, as you would expect, has the ordinary mathematical operators, plus, minus, times, and divide. It also has an operator written as a percent sign but pronounced mod, which means remainder. So 3 mod 2 is 1. Java also has the plus plus operator, which means add 1 to. So if I have a number 3 and I say num plus plus, the number is now 4. Plus plus num also is 4. The question is, does it do the addition before or after returning the value? Normally you don't care. Normally you just do it on a separate line, so it doesn't matter if you put the plus plus before or after, so it's more traditional to put it after. Now, this operator plus plus originated in the days of C, when compilers were not very smart. And it was actually more efficient to say num equals 3 num plus plus than to say num equals 3 num equals num plus 1. With modern compilers, the performance is the same. So don't use plus plus because you think it'll give you any better performance. Use it because it's traditional, because it's brief, because people are used to it, and so forth. The other thing to be careful about is using division on whole numbers. If you have whole numbers, let's say ints, and you take one int I, and its value is 7, and another int j, its value is 2, and you take I divided by j, 7 divided by 2, you would think you would get 3.5. But if the numerator and denominator are both ints, then the result is also an int. It can't be 3.5, so it truncates, and you end up getting 3 instead of 3.5. So be careful with the division on whole numbers. In addition to the very simple operators, there's also a class called math. And the math class has a number of static methods like cosine and random. And these are widely used to do slightly more advanced mathematical operations than just addition and subtraction and division and multiplication and mod. So static methods are methods that you call on the class name. So you call math.power, math.sign, math.random, and so forth. So that's kind of the strategy for how you use it. What are some of those methods in the math class? Well, there's math.pow. So if I take 2 and 3 as arguments, that's 2 to the third. There's math.sqrt for square root. There's math.cbrt for cube root. There's math.exp for e to the x. So if I say math.exp3, that means e to the third. Math.log, if you don't say otherwise, log in Java means log base e. If I want log base 10, I could try to convert, or they have a shortcut log 10 method built in. There's math.sine, math.cosine, math.tangent, math.atangent, and so forth. The thing to remember, just like log, is it uses scientific units. So it's in radians, not in degrees. If you want to convert, there's a math.2 degrees and a math.2 radians that converts from radians to degrees or degrees to radians. There's a bunch of rounding operations where you can round to the nearest number, or you can round up, or you can round down. And perhaps most importantly of all, when you're practicing at the beginning, is math.random. Math.random returns a pseudo-random number. A pseudo-random number means, nothing can really be random in a computer, but a number that acts as though it's random, that you can't predict what the next number is and where it's evenly distributed across the range. So math.random returns a pseudo-random number between 0 inclusive and 1 exclusive. And that's widely used when you're first learning for practicing, so that you can kind of randomly go down different branches of your code. So here's an example. You want to flip a coin 10 times. So you call math.random. That returns a floating point number between 0 and 1. And you compare it to 0.5. So if Java's random number generator is accurate, then half the time it'll do the first branch of the if, and half the time it'll do the second branch of the if. So math.random, A static method call on the math class is very, very useful when you're first learning so that you don't have to keep changing your code, but you can deliberately introduce randomness into your results. There are also some special constants. In the IEEE floating point specification, it says that numeric operations on floating point numbers, doubles, cannot give an error. So what happens if you take 3 and you divide it by 0? Well, the answer is it returns a constant you can still assign to a double called positive infinity. If you take -3 and you divide it by 0, you get negative infinity. If you take 0 and you divide it by 0, you get NaN, not a number, which is kind of funny because in some sense it is a number because you can assign it to a double. You can look up the max value and the min value, the biggest and smallest numbers that you can represent as doubles. And those seem odd to mathematicians, but they seem ordinary to computer scientists. And then finally, there are 2 very useful classes, big integer and big decimal. So the int, lowercase I class in Java, represents a whole number using a fixed number of bits that your computer can operate on efficiently. Big integer represents a whole number using an arbitrarily large number of bits. Now, of course, operations on ints will be faster than operations on big integer. But if you have a situation where you really need to be able to store 142 digits, for example, in a cryptography application, then you can use big integer. And speaking of cryptography applications, it's actually surprisingly easy to determine if a very, 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 very large big integer is prime. And we'll actually use that example later on when we get to the section on parallel programming with fork join.